Question 4. Which expression could be used to calculate the value of x in this triangle? Now we have a right-angled triangle, a known hypotenuse. One of the sides is unknown, but that's the side that we wish to find, so this side x, and we have two known angles. Now if you look at the options, all of them involve the cosine ratio, and cosine is adjacent over hypotenuse. So let's label the sides that we're interested in. So we have the hypotenuse there. This will be our adjacent side. Now one way to help with this question, if you just turn the page around like that, you can clearly see that it's the 40 degrees. This angle here is the angle of interest. This is our theta. So cos of 40 degrees is equal to x over 29. And to make x the subject of the formula, we just multiply both sides by 29. So x is equal to 29 multiplied by cos 40. So the answer is option A. Question 10. What is the area of this triangle to the nearest square meter? Now we have two known sides, but the included angle is unknown. However, we have two other known angles. So if we can work out this angle here, we can apply the area rule for a triangle formula. That's the formula half AB times sine of C. So to work out the missing angle, we'll apply the angle sum of a triangle properties. That is, three angles of a triangle add up to 180 degrees. So 180 minus 50 minus 57, and that equals 73 degrees. And now to work out the area of this triangle, it'll be half times 9.9 times 8.8, so that's the half AB times sine C, sine 73 degrees, and that equals 41.656 ... which is closest to 42 square meters. So the answer is option C. Question 20. Town B is 80 kilometers due north of Town A and 59 kilometers from Town C. Town A is 31 kilometers from Town C. What is the bearing of Town C from Town B? Now the bearing we want to find is represented by this angle theta. But this angle is outside of the triangle ABC. So in order to find angle theta, we need to find another angle inside the triangle. And the best angle to find will be angle alpha, because alpha plus theta equal 180 degrees because they are angles on a line. They are supplementary. But to find angle alpha, we need to use the cosine rule because we have three known sides, but no known angle. So let's apply the cosine rule for angles to find the value of angle alpha. So cos of alpha is equal to 80 squared plus 59 squared minus 31 squared over 2 times 80 times 59. And that just comes from the cosine rule for angles, which you can find on your reference sheet. Simplifying this fraction here, cos alpha equals 223 over 236. To make alpha the subject of the formula, we take the inverse cos of this fraction, 223 over 236, or shift cos on your calculator, and we get alpha equals 19 degrees and 6 minutes, correct to the nearest minute. Now that we have angle alpha, we can proceed to find angle theta. Now angle theta is equal to 180 degrees minus angle alpha, since both of those angles together add up to 180 degrees. 180 minus 19 degrees and 6 minutes equals 160 degrees and 54 minutes, rounded to the nearest degree is equal to 161 degrees. So the answer is option C. Question 27D. A disability ramp is to be constructed to replace steps as shown in the diagram. The angle of inclination for the ramp is to be 5 degrees. Calculate the extra distance d that the ramp will extend beyond the bottom step. Give your answer to the nearest centimetre. Now the first thing to note is that we're dealing with a right angle triangle. So this is really a right angle triangle problem. Either we use Pythagoras Theorem or we can use trigonometry. But in this case, we need two known sides to use Pythagoras Theorem, so this will be a trigonometry problem. a regular right-angled trigonometry problem. So either applying sine, cos, or tan. Now this is our angle theta, which happens to be 5 degrees. This side is the opposite side, this 39 centimeters, and that 39 centimeters comes from the sum of these heights here, 13 plus 13 plus 13 to give us 39. This is the adjacent side. So we have D, but we also have 60 centimeters, which comes from the sum of 30 centimeters and 30 centimeters, the horizontal lengths here. And we need to solve for D. So the ratio that we're dealing with is opposite over adjacent, which means that we need to apply tan. So tan of 5 degrees is equal to 39 over 60 plus D. So that's opposite over adjacent. Multiplying both sides by 60 plus D, we have 60 plus D in brackets multiplied by tan of 5 degrees is equal to 39. Dividing both sides by tan of 5 degrees, we have 60 plus D is equal to 39 divided by tan of 5 degrees. Subtracting 60 from both sides, we get D equals 39 over tan of 5 degrees minus 60. And evaluating this expression here, we have D equals 385.77 and so on. There's more to the decimal, but we want the answer to the nearest centimetre, so therefore D equals 386 centimetres. Question 29C. Raj cycles around a course. The course starts at E, passes through F, G and H and finishes at E. The distances EH and GH are equal. Part 1. What is the length of EF to the nearest kilometre? Let's analyse the diagram there for a moment. We can see that it's a quadrilateral with a diagonal drawn from E to G, just to split that up. And we can see that triangle EFG is a scalene triangle, and triangle EHG is an isosceles right-angled triangle. So the first thing I did was just to fill in the missing angles. So if we have two angles in a triangle, we can find the third angle. So in triangle EFG, 180 degrees minus 139 degrees minus 31 degrees is equal to 10 degrees. Now I've run out of space here, but I would have shown that otherwise. So this angle here, FGE, is 10 degrees. Now in this triangle, EGH, that's an isosceles right-angled triangle. If that's 90 degrees there, these two angles must be equal, and the sum of all three angles must equal 180 degrees. So 180 minus 90 is equal to 90, split evenly among these two angles, so they will be 45 degrees each. Now to find length EF. We have all three angles known. We have two known sides. So the question is, do we use the sine rule for sides or the cosine rule for sides? Now, if we have two sides and an included angle, we can use the cosine rule. Or if we have known side angle pairs, we can use the sine rule. In fact, either rule will work. Since we have two known sides and an included angle that we've just worked out, we could apply the cosine rule, or we can apply the sine rule since we have a known side angle pair, this 82 kilometers and 139 degrees, and we need side EF, and its opposite angle is 10 degrees, and that's known. So I've used the sine rule here, but you could equally use the cosine rule, and we'll get the same answer. So EF over sine 10 degrees is equal to 82 over sine 139 degrees, and making EF the subject of the formula, so multiplying both sides by sine of 10 degrees, EF is equal to 82 multiplied by sine of 10 degrees over sine of 139 degrees, and that equals 21.704 kilometers, and rounded to the nearest kilometer, that's equal to 22 kilometers. Part 2. What is the total distance that Raj cycles to the nearest kilometer? Now we know side EF, that's 22 kilometers, and we know side FG, that's 64 kilometers. We need sides EH and GH. Now sides EH and GH belong in this right angle triangle here, which is an isosceles right angle triangle. Now one of the sides is known, that's the hypotenuse. Now since these two sides are equal in length, we can apply Pythagoras Theorem to find either one of these two sides. So I've just let EH equal x, which is equal to GH, which is also equal to x, just to make the calculation a little bit easier. So using Pythagoras Theorem, x squared plus x squared, the sum of the two shorter sides, is equal to 82 squared. That's the hypotenuse squared. So x squared plus x squared is 2x squared, and that's equal to 82 squared, which is 6,724. Dividing both sides by 2, we have x squared is equal to 3,362, and then taking the square root of 3,362, we get x equals 57.983 kilometers. So the perimeter, or the distance around this track, is 22 plus 64 plus 2 lots of 57.983. So 22 plus 64 plus 2 times 57.983, and that equals 201.966 kilometers. Rounded to the nearest kilometer, that's 202 kilometers. Question 4. What is the value of theta to the nearest degree? Now notice that all three sides are given, so we can use either sine, cos or tan to find angle theta. So I've started by labeling the sides of the triangle. So the 135 meters is the hypotenuse, the 81 meters is the opposite side, and the 108 meters is the adjacent side to theta. So I'm going to use sine to find angle theta. So sine theta is equal to opposite over hypotenuse, so that's 81 over 135. But we need to make theta the subject of the formula. So this is where we use inverse sine, so that's the sine with the little -1 there. So theta itself is equal to the inverse sine of 81 over 135. So that's entered in that way in the calculator. Press equals, we get 36.8698, so on, and that rounds to 37 degrees. So option B. Question 24. What is the value of theta to the nearest degree? Now we can see here that we have a right-angled triangle, and inside the right-angled triangle we have a non-right-angled triangle with two known sides and a known angle. Now to find the angle theta, we will need to find this angle here and then use the angle sum of the right-angled triangle, so the larger triangle, which is obviously equal to 180 degrees being a triangle, to then work out angle theta. So before we worry about theta, we need to find this angle here. I'm going to call that angle alpha. Now, we have two known sides, a known angle, of course, and we have a known side angle pair. So that's a side and an opposing angle that's known. So we can use the sine rule. And by the sine rule, sine alpha over 82 is equal to sine of 26 degrees over 100. And we need to solve for alpha. So multiplying both sides of the equation by 82. So this division by 82 becomes a multiplication by 82 when we move it over the other side. So we have sine alpha is equal to 82 multiplied by sine 26 degrees over 100. And making alpha the subject of the formula by taking the inverse sine of both sides. So alpha is equal to the inverse sine, so that's shift sine on the calculator, inverse sine of 82 multiplied by sine 26 degrees over 100, and that gives us 21 degrees correct to the nearest degree. So this is 21 degrees. Now we can use the angle sum of the right-angled triangle to find the size of angle theta. So theta is equal to 180 degrees minus 90 degrees minus 26 degrees minus 21 degrees, and that equals 43 degrees. So the answer is option C. Question 26a. Triangle PQR is shown. Find the size of angle Q to the nearest degree. So we have an unknown angle and three known sides, which means we need to use the cosine rule for angles. So cos of angle Q is equal to 53 squared plus 66 squared minus 98 squared all over 2 times 53 times 66. And of course we need to make Q the subject of the formula because that's the angle we need to find. But before we do that, we can simplify the fraction on the right hand side. So cos of Q is equal to negative 813 over 2,332. So Q is equal to the inverse cos, shift cos on the calculator, of negative 813 over 2,332, which gives us 110.40 ... degrees. And of course, rounded to the nearest degree, that'll be 110 degrees. Question 28a. A compass radial survey of the field ABCD has been conducted from O. Find the area of the section ABO to the nearest square metre. So section ABO is this triangle, and to find the area of that triangle, either we use half base times height, but clearly we don't have the height, or we can use half AB sine C if we have two sides or two known sides and the angle in between, or the included angle. So we have two known sides, we just need this angle here. There's two ways we can find that angle. So this is angle AOB. Either find the number of degrees from point A to north, and then from north to point B. So 310 to north, that's 50 degrees. 50 degrees plus 21 degrees is 71 degrees. Or you can find the reflex angle. So this is the angle here. And then subtract that from 360 degrees, and that will also give you the angle AOB, the included angle in the triangle. So we're going to apply the area rule for triangles. So firstly, we need to think of a strategy. The strategy is this strategy here. Next, I'm going to find reflex angle AOB. So that's 310 minus 21. So 310 minus 21. And that equals 289 degrees. So to find the non-reflex angle AOB, or the included angle in the triangle, it's 360 minus 289, which equals 71 degrees. So now that we have the included angle and the two known sides, we can now apply the area rule for triangles to find the area of triangle ABO. So area of triangle ABO is equal to half multiplied by 75 multiplied by 60 multiplied by the sine of 71 degrees, which equals 2,127.416 ... square meters, but we need to answer to the nearest square meter, so that equals 2,127 square meter, correct to the nearest square meter. Question 23. The following information is given about the locations of three towns, X, Y, and Z. X is due east of Z, X is on a bearing of 145 degrees from Y, and Y is on a bearing of 060 degrees from Z. Which diagram best represents this information? Now the first point, X is due east of Z, implies that X is situated to the right-hand side of Z. So it's either options A or C, since X is on the right-hand side of Z. Now the third point, Y is on a bearing of 060 degrees from Z, is satisfied in both these options. Now the second point, X is on a bearing of 145 degrees from Y, is the one that is going to require a little bit more time. Now to help with the explanation, what I've done is I've redrawn the triangle here, it's not the scale of course, and X is due east of Z, and Y is on a bearing of 060 degrees from Z. So I've filled in another angle here, so this is 30 degrees because it's complementary to 60 degrees. Of course, since X is due east of Z, so this is the east-west axis, and there's 90 degrees between north and east. Now we know that X is on a bearing of 145 degrees from Y. So what I've done is I've drawn another north-south axis, so from Y but just sort of upwards in a northerly direction. And these two north-south axes are obviously parallel with each other. So that's 145 degrees. Now, since these two sets of axes are parallel, we can use parallel line geometry. So if that's 60 degrees here, this angle here, so NYZ, is co-interior, which means that these two angles must add up to 180 degrees. So that's 120 degrees there. And angles at a point add up to 360 degrees. So 360 minus 120 minus 145, actually I might just write that here, so 360 minus 120 degrees minus 145 degrees will give us 95 degrees. And so the correct answer is option C. Question 26b. Calculate the value of h correct to 2 decimal places. Now we're dealing with a right-angled triangle, which means either Pythagoras Theorem or right-angled trigonometry will need to be applied. Now Pythagoras Theorem is applied when we have two known sides, and in this case we've only got one known side and the other side's unknown, and we have no idea what's going on with the third side, which leaves us right-angled trigonometry. So we have a known angle, we have a known side, we'll need to find the unknown side. The next thing is whether we use sine, cos, or tan. And that depends on where the sides are relative to the 28-degree angle. Now the 5 is opposite the 28 degrees and h is the hypotenuse. So from Sohcahtoa, S-O-H, we need to apply the sine ratio. So sine of 28 degrees is equal to 5 over h. So that'll be the first equation I would write. The next thing is I would need to solve for h. Now notice that h is in the denominator, not in the numerator. The next thing is to multiply both sides by h, or I could move the h over and multiply the sine 28 degrees by h, and that equals 5. Now to make h the subject of the formula, we would need to divide both sides by sine 28 degrees. So h equals 5 divided by sine 28 degrees. And evaluating that, we get 10.65. Question 28b. A radial compass survey of a sports centre is shown in the diagram. Part 1. Show that the size of angle AOB is 114 degrees. So firstly, let's consider the angle between A and north. So from 320 to north is 40 degrees. So the way we can work that out is 360 degrees minus 320 degrees is equal to 40 degrees. Next, from north to point B is 74 degrees. So 40 plus 74 is equal to 114 degrees as required. Part 2. Calculate the length of the boundary AB to the nearest metre. Let's go back to the diagram. So there's boundary AB. This is part of triangle AOB. Now, the other two sides of the triangle are known. So OA and OB, the lengths of those two sides we know. So 287 metres and 211 metres. We also know angle AOB, which was worked out, of course, from part 1, which is 114 degrees. So two known sides and an included angle. So that's the angle in between. So do we use the sine rule or the cosine rule? Now, two known sides and an included angle, we use the cosine rule. So AB squared is equal to 287 squared plus 211 squared minus 2 times 287 multiplied by 211 multiplied by cos of 114 degrees. And that evaluates to 176,151.5018. So I've left everything in exact form. So I just copied down all the characters or all the numbers from the calculator screen, didn't round, and it's good practice to keep values unrounded right up until the very end and then round right at the end. Now we need to take the square root. This value looks far too big for that to be the length of the side of triangle AOB. And I guess that's another check that you can do to sort of, is your answer reasonable? 287, 211, 176,000. So the last step is to take the square root because we don't want AB squared. And we get AB equals 419.704 ... Of course, I don't write all the decimals at this point because we just need the answer to the nearest metre. So AB equals 420 metres. Part 3. Find the area of triangle AOB in hectares correct to two significant figures. So let's go back to the diagram. So we've worked out side AB, which is 420 metres, but that's a rounded figure, so I'm not going to use that. But I will use side OA and OB since these are far more accurate, and that's the original data that's supplied in the question. We also know angle AOB, of course we've worked that out previously as well, which is 114 degrees. So just like the cosine rule, we can use the area rule for a triangle because we have two known sides and an included angle. So that's the half AB sine C formula. So let's do that. So area equals half times 287 times 211 times sine of 114 degrees. And just expressing the answer without rounding, it's 27,660.78614 square meters. Next, we need to convert that to hectares, and there are 10,000 square meters in a hectare. So we'll divide that answer by 10,000. And that gives 2.766 ... hectares. Now the ... just means that there's more decimals. However, we need to answer correct to two significant figures. So we're only interested in the first number and the second number, so the 2 and the 7. The number after the 7 just determines whether the 7 stays as a 7 or whether it gets rounded up. And because the value after the 7 is 5 or more, the 7 needs to be rounded up to an 8. So the area of this triangle is 2.8 hectares, correct to two significant figures. Question 7. The diagram shows a radial survey of a field ABCD. In triangle AOB, what is the size of angle AOB? So first step, let's locate triangle AOB. So there's AOB, so it's this north-facing triangle. Angle AOB is this angle here. Okay, this is where ray OA and OB come together, okay, at the vertex. So the angle we want is this angle here. Now, there's two ways we can do this. One way would be to find this angle here, this angle there, and this angle here, and then add them together and subtract it from 360 degrees, and that could work, okay? And that'll give you angle AOB. Or we could use the fact that to go from point A and rotate clockwise to north, so 300 to north, which is 360 degrees, we need to move or rotate another 60 degrees to get to north. Once we get to north, to rotate from north then to point B, it's like we're starting from 0 again. So 0 and 360 degrees are kind of the same thing, really. It's just sort of, you do one rotation around, you get to 360 degrees, and then it sort of starts again, kind of like a clock, isn't it? It goes back to 12 o'clock again. So from north to point B, okay, B is on a bearing of 51 degrees, or 0.51 degrees. So that angle is 51 degrees. And the sum of these two angles there, because they're adjacent angles, then gives you the size of angle AOB. So angle AOB is equal to 60 degrees plus 51 degrees, which is equal to 111 degrees. And that's option B. Question 22. The area of the triangle shown is 250 square centimeters. What is the value of x correct to the nearest whole number? Now, given that we have the area of the triangle, we don't know what the perpendicular height is. This is an application for the sine rule for the area of a triangle. This is the half AB sine C. So let's use that. So we know that the area of the triangle is 250 square centimeters, is equal to half AB sine C. So this can be A, this can be our B. So half multiplied by 30 multiplied by x multiplied by sine 44 degrees. Let's rearrange this formula now to find x. So leaving the 250 where it is, moving the half over, we're going to divide by half, then divide by 30, and then divide by sine of 44 degrees, and that gives us x. So let's enter that in and see what we obtain. So 250 divided by half, divided by 30, divided by sine of 44 degrees, and we get 23.99, which is equal to 24, correct to the nearest whole number, option D. Question 30E. From point S, which is 1.8 meters above the ground, a pulley at P is used to lift a flat object F. The lengths SP and PF are 5.4 meters and 2.1 meters respectively. The angle PSC is 108 degrees. So part 1, show that the length PC is 6.197 meters, correct to 3 decimal places. So this one we can see that it's clearly going to be the cosine rule. Okay, so we want PC here. So we're not focusing on this right angle triangle, we're focusing on triangle PSC. We have an angle and we have 2 sides about that angle. So 2 sides and an included angle. This is going to be the cosine rule. So PC is equal to, I'm going to do this all in one step in fact, the square root of, and then we're going to apply the cosine rule. So that's going to be 5.4 squared plus 1.8 squared minus 2 times 5.4 times 1.8 times cos of 108 degrees. And I've just taken the square root of the whole lot because, as you know, with cosine rule, it's a squared equals b squared plus c squared, so on and so on. So I'll just take the square root and do it all at once. Okay, so 5.4 squared plus 1.8 squared minus 2 times 5.4 times 1.8 times cos 108 degrees, and we get 6.197 as required. I'll write as required. You don't have to, but because you're asked to prove it, so and there's the requirement to prove. So that's it for that for part 1. Part 2. Okay, calculate h, the height of the object above the ground. So it's this there. Okay, or this height there. Okay, now we have PC, and in fact I might just write this measurement, the one that we just worked out before. In fact, it's even given to us. So there's 6.197. We have a right angle triangle there, so I'll just make that a bit more apparent. And we just need really another angle. Okay, and we could then work this out. Okay, so if we can find another angle, so if we can find this angle here, and I know that we can then find this angle here, and then we can use regular right angle trigonometry. So that's the thinking process. So as you're attacking this question, you need to say to yourself, well, I've got a right angle triangle here. I need another angle. I can then work out PE, this length PE. I then take away 2.1, and then I'll have H, this remainder there. Okay, so what we'll do is I'm going to put an angle there. Let's call that angle theta, and I'm going to call this one here angle alpha. So the goal is to find this angle alpha there. Okay. In fact, we've got 5.4, which is opposing alpha. We can use the sine rule here. Okay, so when you have side angle pairs, so 6.197 is opposing this 108, 5.4 meters is opposing this theta, we can use the sine rule. So let's do that. Okay, so what I'm going to do is I'm just going to define theta first of all. Theta equals angle PCS. So I'm just going to write that down first. PCS. Okay, so by the sine rule. Okay, we have sine of theta. Okay, so back to the diagram. Sine of theta over 5.4. Okay, is equal to sine of 108 over 6.197. Okay, we'll just use that rounded number, the answer that we got in the previous part. So now we need to just make theta the subject of the formula. Okay, so just to save a bit of space, I'm just going to continue it on to the next line. Sine of theta we're just going to multiply both sides by 5.4. So that's equal to 5.4 multiplied by sine 108 over 6.197. And then we just make theta itself the subject by taking the inverse sign or shift sign of the right hand side. So theta is equal to inverse sine, I'll just try to save a bit of space here, of 5.4 sine 108 over 6.197, and I'm just going to answer to the nearest minute. Okay. So shift sign, and 5.4 sine of 108 over 6.197. Forget the close brackets there. Okay, and we get 55 degrees and 58 minutes. Okay, so that's this angle there. So this angle there. Okay, 55 degrees, 58 minutes. So theta, okay, so let theta equal, and that's going to be ECP. Okay, and moving on, okay, theta is equal to 90 degrees minus, okay, minus theta. Okay, so 90 minus my previous answer, and that's going to be 34 degrees and 2 minutes. Okay, so now we have enough to be able to answer this question using basic right-angled trigonometry. So I'm just going to write this, a bit of information on the diagram. So there's 34 degrees and 2 minutes. Okay, now we can find length PE. Okay. So we have an opposite side, okay, and we have a hypotenuse. So we need to use the sine ratio there. Okay, so sine of 34 degrees, 2 minutes is equal to PE over PC. Okay, so over PC, so it's going to be 6.197. Okay, and PE is equal to 6.197 multiplied by sine 34 degrees. Hopefully I can just make it in between just before I get to that margin. Yep, and I just do. Right. So let's evaluate this one. 6.197 multiplied by sine 34 degrees, 2 minutes. And we get 3.4683. Okay, so that's this whole length here, PE. So H, which is got to subtract 2.1 from that answer. Okay, so H is equal to 3.4683 minus 2.1, which is 1.368. And that's it to 3 decimal places. In fact, just rounding it straight off the calculator screen there, I think we can just leave it at that. And that's meters, and that's correct to 3 decimal places. Question 25. The diagram shows towns A, B, and C. Town B is 40 kilometers due north of town A. The distance from B to C is 18 kilometers, and the bearing of C from A is 0.25 degrees. It is known that angle BCA is obtuse. What is the bearing of C from B? I'm just going to zoom in on this question, and just on the diagram in particular. So we want the bearing of C from B. In other words, this is really the angle that we want. So in order to find this angle theta, we really need to find this angle here, this angle alpha here. But in order to find this angle alpha, we need angle BCA. Okay. Now, we have some known sides. So we have 18 kilometers, side BC, which is opposite angle BAC, this 25 degrees. Now, we have a side angle pair, so we're going to use the sine rule to find angle BCA. Once we find that, angle sum of a triangle to find alpha, and then supplementary angles to find theta. Okay, so let's find BCA first. Okay, so sine of BCA over 40 kilometers is equal to sine of 25 degrees over 18 kilometers. Now let's rearrange the formula to make angle BCA the subject of the formula. Okay, so sine of BCA is equal to 40 sine 25 degrees over 18, and then angle BCA is equal to inverse sine of all this, 40 sine 25 degrees over 18. Okay, and we can answer that one to the nearest minute, and we'll round it to the nearest degree in the end. So shift sine, fraction, 40 sine 25 degrees over 18, close bracket, and we get 69 degrees and 55 minutes. Now to find angle alpha is equal to 180 minus 25 minus angle BCA. Okay. So 180 minus 25 minus BCA, so that's in the answer memory of the calculator, and that's going to be 85 degrees and 5 minutes, which means that angle theta, which is the bearing that we want, is going to be 180 degrees minus 85 degrees and 5 minutes, and we get 94 degrees and 55 minutes. Which is closest to 95 degrees when rounded. So it's going to be option B. Question 30C. A school playground consists of part of a circle with center O and a rectangle as shown in the diagram. The radius OB of the circle is 45 meters. The width BC of the rectangle is 20 meters, and angle AOB is 100 degrees. What is the area of the whole playground? Correct to the nearest square meter. So if we look at this shape a little bit more closely, we can see that we have a sector, sort of the major sector here. We have a triangle component, and we also have a rectangular component there. So to find the area of the sector, that's sort of fairly easy. Okay, we can see here that we actually need this angle here. Okay, and that's going to be 260 degrees, since angles at a point add up to 360. The rectangle, in order to find that, we need length DC, which we don't have. Now the triangle AOB, we can use the sine rule for area of a triangle. That's the half AB sine C. So that's easy enough. But in order to answer the question completely, we need length AB, which is equal to length DC, so we can find the area of this rectangular part there. Now, to find AB, there's one of two ways we can do this. We can either use the cosine rule, since we have two sides, or two known sides, and an included angle, and that's fairly easy. Or you could split this triangle down the middle. Because it's an isosceles triangle, when you split the triangle, when you draw a perpendicular, in fact, you can split this triangle into two identical right-angled triangles, and you could use just basic right-angle trigonometry, and that would work as well. So you have 100 degrees, that will be 50 degrees, 50 degrees. This would be 40 degrees there and 40 degrees there. Since also angle sum of a triangle, okay, has to add up to 180 degrees. And being isosceles, these base angles must be equal. So that's the approach that I'm going to take for this solution. So let's work out AB first, since we need that to be able to really unlock this, this entire question, or to answer it completely. So AB, okay, is equal to, now I might just put a sort of a letter X there, and there's another letter X there, okay. So AB is equal to 2 multiplied by, we need the adjacent side here, don't we? So that's going to be X on 45 is equal to cos of 40. So that's going to be 45 cos of 40. 45 cos of 40 will give you X. 2 times 45 cos of 40 degrees will give you 2x. So it will give you this entire length AB. And that's going to be equal to, in fact, I'll write it on the next line here. So 2 multiplied by 45 cos of 40, and we get 68.94399. I might just write the whole answer, and I'll just do all the rounding at the end. 94399, actually 999, 88. Okay, and that's in meters. Now that we have AB, we can now proceed to answer the question. So area of major sector. Okay. So the fraction of the circle that we have is 260 over 360. Okay, so 260 over 360 multiplied by pi r squared. So pi multiplied by the radius, which is 45 meters, and we're going to square that. Okay. 260 over 360 multiplied by pi multiplied by 45 squared, and we get that answer 4594.579256 square meters. Okay. Now area of triangle AOB. Okay. And we have half AB sine C, so half multiplied by 45 multiplied by 45. So again, the two known sides and the included angle multiplied by sine of 100 degrees. And I'll just put the answer here since I'm just running out of space. Okay, so half multiplied by 45 multiplied by 45 multiplied by sine of 100, and we get 997 with a decimal component, and that's that. And lastly, triangle ABCD. Sorry, rectangle ABCD. Okay, and that's just length times width. Okay, and we have the length already, which is 68.943, and so on. So 68.9439988 multiplied by the width of this rectangle multiplied by 20. Okay, so 68.9439988 multiplied by 20, and that's the area of the rectangle. So 13 0.78.8799998 square meters. Okay, so it would be a mark for this, a mark for that, a mark for this, a mark for this, and then obviously a mark for the correct answer. So total area, okay, is equal to 4594.579256 plus 997.117849 plus 1378.879998, and need to answer to the nearest square meter. Okay, so 4594.579256 plus 997.117849 plus 1378.879998, and we get 6970.577 ... Okay, we need to just round it to the nearest square meter anyway, so I don't have to write the entire decimal. So that's equal to 6971 square meters, correct to the nearest square meter. Question 8. The diagram shows a right-angled triangle. What is the value of theta correct to the nearest minute? So this is just basic trigonometry. There's our theta. This is our opposite side. This is our adjacent side. Opposite over adjacent, that's going to be the tan ratio. So tan theta is equal to opposite over adjacent, so that's going to be 5.3 over 1.9. Theta is going to equal inverse tan, so that's shift tan on the calculator, 5.3 over 1.9. So let's enter that in now. Okay, so shift tan, got out the negative 1 there. Okay, fraction 5.3 over 1.9, close bracket. And now we press the degrees, minutes, seconds button, this button here. Okay, so, and it's 70 degrees, 17 minutes. Okay, so option B. Question 26D. A sewer pipe needs to be placed into the ground so that it has a 2-degree angle of depression. The length of the pipe is 15,000 millimeters. How much deeper should one end of the pipe be compared to the other end? Answer to the nearest millimeter. So what we need to find is that side there. And we're just going to use basic right-angle trigonometry. Here's our theta. That's our opposite side. This is our hypotenuse. So we could write sine of 2 degrees is equal to opposite over hypotenuse. That's 15,000. Making x the subject of the formula, x is equal to 15,000 multiplied by sine of 2 degrees. And we get 523.49. Okay, but it says to answer to the nearest millimeter, so we can round that to 523 millimeters. Question 30C. The diagram shows the location of 3 schools. School A is 5 kilometers due north of School B. School C is 13 kilometers from School B, and angle ABC is 135 degrees. So part 1, calculate the shortest distance from School A to School C to the nearest kilometer. Now, looking at this diagram, we have a triangle, we have 2 known sides and an included angle. That means it's cosine rule, so let's use that. So we need to find AC, so the cosine rule goes AC squared is equal to 5 squared plus 13 squared minus 2 times 5 times 13 multiplied by the cosine of 135 degrees. So let's work that out. We're not going to round it until the very end. Okay, so we have 5 squared plus 13 squared
minus 2 times 5 times 13 multiplied by cos of 135 degrees. So AC squared is equal to 285.92388816. But we want AC. Okay, so just like with Pythagoras Theorem, we need to take the square root of the previous answer. Okay, 92388816. So square root of our previous answer. Okay, and we get 16.9. Okay, however, we need to round it to the nearest kilometre. So 16.9 is equal to 17 kilometres to the nearest, correct, to the nearest kilometre. Okay, so I'm going to add this on to the diagram. Okay, so that's 17 kilometres. Let's have a look at part 2. Determine the bearing of school C from school A to the nearest degree. So this means that we need to find school C, the bearing of school C from school A. So we actually need this angle here. Okay. Now from north to south is 180 degrees. So in actual fact we need this angle there. Okay, angle BAC. So I'm just going to put a theta there. So if we can find that angle, we can add it to 180 degrees, we get the bearing. Okay. So this means then that we may have to look at another rule. Now let's see if we have some side angle pairs, because maybe the sine rule could work here. We have 17 kilometers opposing 135 degrees. So there's a known side angle pair. We have theta opposing 13 kilometers. So there's a side angle pair where one of the, the distance is known, which means that we can then use the sine rule to find theta. So let's do that. Okay. So, and we need to find an angle. So I'm going to write it this way. Okay. Sine 135 degrees over 17. Okay, so that's sine 135 over 17. Okay, that's a sine A over A is equal to sine of theta over 13. Okay, so that's sine of theta over 13 kilometers. Let's solve this. Okay, so sine of theta. Okay, I'm going to move the 13 over to the other side. So that's going to be 13 multiplied by sine 135 degrees over 17. Okay. And theta is equal to the inverse sine. Okay, so we don't want sine theta. We actually want just theta on its own. Okay, of all this. Okay, so 13 multiplied by sine 135 degrees over 17. Okay, so let's quickly work that out. So shift sine. Okay, and in fact, I'll do it this way. 13 multiplied by sine of 135 over 17. Okay, close brackets. We get 32.73. Okay, I might just, okay, 32 degrees, 44 minutes, in fact. Okay. So the bearing of C from A is going to be 180 degrees plus that angle we just found. Okay. Okay. Of C from A, okay, is equal to 180 degrees plus 32 degrees 44 minutes. Okay, so let's add 180 to that, and we get 212.733 degrees. Okay. Okay, but we need to round that to the nearest degree. So that's equal to 213 degrees, correct, to the nearest degree. Question 7. The diagram shows the positions of towns A, B, and C. Town A is due north of town B. An angle CAB is equal to 34 degrees. What is the bearing of town C from town A? Here's our town C, here's our town A. The bearing of town C from town A is measured from true north clockwise. So from north to south is 180 degrees, plus 34 is 214 degrees. Option C. Question 12. The diagram shows a triangle with side lengths 8 meters, 9 meters, and 10 meters. What is the value of theta marked on the diagram to the nearest degree? This is an application of the cosine rule for unknown angles. I'm going to label the triangle first with the unknown angle as angle A, uppercase A. Then I'll label the other two vertices, and I'm going to label the sides. Okay? They need to be opposite the vertices with the same letter, just a lowercase version. So cos of A is equal to 8 squared plus 9 squared minus 10 squared over 2bc. So 2 times 8 times 9. We need the A on its own, so that's going to be inverse cos of 8 squared plus 9 squared minus 10 squared over 2 times 8 times 9. Entering in that into your calculator. Okay. So I'll just brighten it up a little bit there. Shift cos and 8 squared plus 9 squared minus 10 squared over 2 times 8 times 9. And we get 71.79, and the answer that's closest to that is option D, 72 degrees. Question 30C. The diagram shows two triangles. Triangle ABC is right angled, this is triangle here, with AB equals 13 centimeters and angle ABC equals 62 degrees. In triangle ACD, so that's this triangle here, AD equals X centimeters and angle DAC equals 40 degrees. The area of triangle ACD is 30 square centimeters. What is the value of X correct to one decimal place? So in order to be able to find X, okay, we have the area of this triangle ACD. We also have a known angle. So there's two pieces of information here. We need a third piece of information on this triangle ACD in order to be able to find side X. Now, given that we're working with the area of a triangle, that implies we need to use the sine rule for the area of a triangle. That's the half AB sine C. And then we're going to rearrange the formula to then find the value of X. But before we can do that though, we need this side AC here. This side CD, we can't do anything with that. Okay. So AC, however, can be found using this right angled triangle. Let's call this side Y. Let's call this our angle theta, and we can use our sine, cos, and tan ratios to be able to work out Y, and then we can use that to then work out X. Okay, so that's the logic. So let's work out Y first. Y is the opposite side to theta. We have a hypotenuse. That's our opposite side, which means we're going to use the sine ratio. So sine of 62 degrees is equal to Y over 13. Rearranging this formula to make Y the subject, we multiply the sine 62 by 13. Y is equal to 13 multiplied by sine 62 degrees. And if you like, we can evaluate that. Okay, so 13 multiplied by sine of 62 degrees. And I'm going to write the entire decimal. I'm not going to round this yet. Okay, so in order to maintain some level of accuracy as we work this out. So 11.47831871. So that's our sort of our first stage, or our first major step, is to work out this value of Y. Now let's use triangle ACD to work out this side here, this unknown side X there. Okay, so in triangle ACD, so this is where we're working now. Okay, area is equal to half multiplied by A multiplied by B multiplied by sine of c. Sometimes I like to start off with the formula, because that way I know what I need to do. And if I need to rework this formula or rearrange it somehow to make one of these variables the subject of the formula, we can do that. Let's substitute in some known values. We have the area of the triangle, that's 30, equal to half, multiplied by, now we have a value y, we just found that, so that's going to be 11.47831871 multiplied by x, that's our side b, multiplied by sine of 40. Okay, so it looks like a bit of a mess, but it's actually not as bad as all that. Let's rearrange this, make x the subject of the formula. Now, because these are all multiplied together, all we need to do is this. Starting off with the 30, we're going to divide it by half. We're going to divide it by this number here, 11.47831871, and then we're going to divide it by sine of 40. Everything's just divided. Why? Because it's the opposite of multiplication, the inverse operation. And that's equal to x. Therefore, x equals, I'm going to enter all that into the calculator. Okay, so 30 divided by half divided by 11.47831871. Do not rush this. Divided by sine of 40. And we get 8.13215 ... We don't need that many decimal places because we're practically at the final answer now. That's centimeters. We need to round it though to 1 decimal place. And so that's equal to 8.1 centimeters, correct to 1 decimal place. Question 4. Which compass bearing is the same as a true bearing of 110 degrees? What we'll do first is we'll draw a quick compass rose. There's north, okay, that's 0, 0, 0 degrees using 3-figure bearings. 110 degrees, okay, that's just south of east, isn't it? So that's 0, 9, 0. There's south, which is 180 degrees. 110 would be somewhere there. Okay, so there's 110 degrees. So that's going to be south 70 degrees to the east, because from south measuring back towards east, we need to go back 70 degrees. Okay, so this bearing here is south 70 degrees to the east. And so the answer is C. Question 12. An owl is 7 meters above ground level in a tree. The owl sees a mouse on the ground at an angle of depression of 32 degrees. How far must the owl fly in a straight line to catch the mouse, assuming the mouse does not move? First thing we do, let's draw a wireframe sketch. There's our tree. There's the ground. Here's the straight line distance. There's the mouse. Okay. There's the owl. 90-degree angle. Now we'll draw in our angle of depression, which is drawn reference to a horizontal. Now the angle of depression and the angle of elevation are in fact identical, and from the owl, from the top of the tree to the ground, is 7 meters, and we want to find the straight line distance. According to Sohcahtoa, this is going to be sine because it's opposite over hypotenuse. So sine 32 degrees is equal to 7 over x. X is equal to, you can just move the 7 on top of the sine 32, and then just enter that into your calculator. So I'll just do that now. 7 over sine 32 degrees, and we get 13.2, which is option D. Question 17. The diagram shows a triangle with sides of length x centimeters, 11 centimeters, and 13 centimeters, and an angle of 80 degrees. Here's the diagram. Use the cosine rule to calculate the value of x correct to two significant figures. So to get full marks, we need to use the cosine rule, show the working out, of course, and make sure that we round the answer correctly. So, cosine rule. X squared is equal to 13 squared plus 11 squared minus 2 times 13 times 11 times the cosine of 80 degrees. So, working out that line there, so that's 13 squared plus 11 squared minus 2 times 13 times 11 times the cosine of 80. Okay, and we get 240.3366212. But of course we want the square root of that. Okay, it doesn't seem realistic that we have a side of the triangle that's 11 centimeters, a side that's 13, and another side that's 240. So we need to take the square root. Okay, so x is equal to the square root. Notice that I haven't rounded. We do all the rounding at the very end. Okay, so just to save a bit of time, square root, answer key, equals 15.5027. So what I'm going to do is I'm just going to write down a few extra decimal places, or a few extra significant figures in this case. Okay, but we want two significant figures. Okay, so that means first significant figure, second significant figure. We don't go any further. However, the third significant figure will round the second significant figure upwards. Okay, so that's going to equal 16 centimeters correct to two significant figures. Question 22. Two right-angled triangles, ABC and ADC, are shown. Calculate the size of angle theta correct to the nearest minute. Now let's analyze this diagram for a moment. We have triangle ADC, that's a right-angled triangle. We have a triangle ABC, that's also a right-angled triangle. In fact, AC is a common hypotenuse. Now, when you think of right-angled triangles, two things should automatically come to mind: Pythagoras Theorem and trigonometry. Now, we want to find angle theta, that's really the prize here. But in order to find angle theta, I need two sides of this triangle ABC, two known sides. I've only got one known side. So I need side AC. BC, at the moment I've got no chance of finding that. But AC, we can, and we can use triangle ADC, this triangle here, and Pythagoras Theorem, of course, to calculate the length of AC. So let's do that. So by Pythagoras Theorem, AC squared is equal to 2.5 squared plus 6 squared. 2.5 squared plus 6 squared, and we get 42.25. Therefore, AC is equal to the square root of 42.25, and let's express that in decimal. We could either leave it in third form, or we can express it in decimal. In fact, it's only 6.5. It's not a decimal that sort of goes on forever. Okay, so that's equal to 6.5 centimeters. In fact, so that's this one here. We could add that onto the diagram. Okay, now if you turn the page round, right, you can see the right angle triangle there, right? And we have our angle theta. This would be our adjacent side. This would be our hypotenuse. Now, according to Sohcahtoa, okay, if you want to use Sohcahtoa, okay, that's your basic right-angled trigonometry. This is going to be cos, isn't it? Okay, so cos of theta is equal to adjacent over the hypotenuse. So that's 4.9 over 6.5. Make theta the subject of the formula. So we move the cos over, and it becomes inverse cos. So cos with a -1, a shift cos on your calculator. 4.9 over 6.5. Okay. So shift cos. Okay. 4.9 over 6.5. We get 41.0753, but we want it to the nearest minute. Okay, so we'll press this button here, degrees, minutes, seconds. We get 41 degrees. Okay, if you can see that, yep, 4 minutes, 31.26 seconds. Now we need it rounded to the nearest minute, correct to the nearest minute. So that's going to be 41 degrees. The 4 minutes is going to become 5 minutes because it's 30 seconds and above, rounds the minute up by 1. Question 35. A compass radial survey shows the positions of 4 towns, A, B, C, and D, relative to point O. The area of triangle BOC is 198 square kilometres. Calculate the bearing of town C from point O, correct to the nearest degree. So let's have a look at the radial survey. As we go from one town to another, whatever the angle is inside the triangle is added to the bearing to give us the bearing of the next town clockwise. So in order to get the bearing of town C, we need the bearing of town B plus this unknown angle here. So now let's focus on triangle BOC. We need this angle here, we know the area, and we know 2 sides. And the angle that we want is the included angle between the 2 known sides. So we need to use the sine rule for area of the triangle. So, in triangle BOC, 198 square kilometres is equal to half AB sine C. So half multiplied by 25 multiplied by 16 multiplied by sine of C. So let's solve now for C. So half multiplied by 25 multiplied by 16 is equal to 200. Okay. Now we need to make sine C the subject of the formula. Okay. So sine C is being multiplied by 200. When we move the 200 over, 198 divided by 200 is equal to sine of C. But we need angle C to be the subject. So we take the inverse sine or shift sine on the calculator of the left hand side, divide that by 200 is equal to C. And we get 81.89 degrees. So we'll work to 2 decimal places, but eventually we're going to round it to the nearest degree. Okay, so this one's going to be 81.89 degrees. We're just going to add it to the bearing of town B, and we'll get the bearing of town C. So okay, is equal to 125 degrees plus 81.89 degrees. We always round at the end. Okay, so plus that, add that to 125, we get 206.89. 9 degrees, and rounding that to the nearest degree, That's going to be 207 degrees.
Question 16. Consider the triangle shown. Find the value of theta correct to the nearest degree. So first of all, let's classify the type of triangle. It's a right-angled triangle. We're not going to need the sine rule or the cosine rule. Okay, so just regular right-angled trigonometry, Sohcahtoa. What I'm going to do is I'm going to mark in theta first of all, just mark it in a little bit clearer by just drawing the arc in, just to make it apparent where it is. So I can mark in also the various sides. This is the opposite side. This would be the adjacent side. Since it's closest to theta, this would be the hypotenuse. So I'm also going to write Sohcahtoa here. Okay. I've got opposite, adjacent, two known sides there. It's going to be tan. So tan of theta is equal to opposite over adjacent. Okay, so that's going to be 8 over 10. All right. Now, we need theta to be the subject of the formula there. And we're going to move tan to the other side by using the inverse of tan. So this is tan to the -1 using the shift key on the calculator, and then before we press the tan button. 8 over 10. And let's enter that in now. So shift tan, 8 over 10. And we get 38.659. Okay, 38.659 ... but we need the answer to the nearest degree. So that'll be 39 degrees to the nearest degree. Now part B says find the value of x correct to 1 decimal place. Now, being a right-angled triangle, and we have two known sides, there's two ways we can do this. Either we can use trigonometry again, and we could use cos or sine or whatever, actually whichever one you like. You got all three sides. Well, you got two sides known. Actually you've got an angle. So you could use, in fact, you could use sine or cos, but why bother? You've got two known sides, two of the shorter sides. Why don't we just use Pythagoras Theorem? It's just a lot easier. So you've sort of got a choice here. So by Pythagoras Theorem, okay, x squared is equal to 8 squared plus 10 squared. Okay. All right. So 8 squared plus 10 squared, 164. All right. And we need to take the square root of that. So x is equal to square root of 164. And that gives us 12.806. Okay. ... But we want it correct to 1 decimal place. So that's going to be 12.8 correct to 1 decimal place. Question 31. Mr. Ali, Ms. Brown, and a group of students were camping at the site located at P. Mr. Ali walked with some of the students on a bearing of 035 degrees for 7 kilometers to location A. Ms. Brown, with the rest of the students, walked on a bearing of 100 degrees for 9 kilometers to location B. So part A, show that the angle APB is 65 degrees. So there's our APB there. Let's mark in some information on this diagram. So we know that Mr. Ali walked on a bearing of 035 degrees, which is just 35 degrees clockwise from north. So we can mark that in there. Now, the bearing NPB is 100 degrees, so that's that bearing there. Okay, and it's obviously the difference between the 100 degrees there and the 35 degrees here, which then gives us this angle there. Okay, so angle APB, okay, is equal to 100 degrees minus 35 degrees, okay, which equals 65 degrees. Okay, or otherwise, if you want to show a little bit more information, a little bit more reasoning, we could say that's angle NPB minus angle NPA as our reason. All right. Now, part B, find the distance AB. Okay. Now, just before we do that, I might just mark in the 65 degrees there. We want the distance AB. So let's just draw that in on the diagram. Okay, so just lightly with pencil. I would highly recommend that you use pencil at this point, just in case if you make a mistake, okay, you can always rub it out. Okay, so if you use pen at this point, you make a mistake on the diagram, it may ruin your diagram. All right, find the distance AB. Now we have a non-right-angled triangle. That means either sine rule or cosine rule. If it's side angle pairs or there are known side angle pairs, so an angle and an opposite side are known. Okay, so for example, this angle and this side have to be known, or this side and this angle have to be known, and so on. That's sine rule. Otherwise, if it's two known sides and an included angle, so this sort of angle in between, then it's cosine rule. And in this case, it will be cosine rule. So let's use that. Okay, so that's going to be AB all squared, okay, is equal to 7 squared. Okay, so it's like your A squared equals B squared plus C squared minus 2BC times cos A. Right, and you get that from the formula sheet. So plus 9 squared minus 2 times 7 times 9 times the cosine of 65 degrees. All right, and let's enter that in the calculator now. So 7 squared plus 9 squared minus 2 times 7 times 9 times the cosine of 65, and we get 76.75009902. Okay, and AB would have to be the square root of that. Okay, so 76.75009902. Okay, and we get 8.76. We'll probably round it to 2 decimal places is probably sufficient for our needs. So 8.76 kilometers. So let's mark that on our diagram as well. 8.76 kilometers. All right. Now, part C. Find the bearing of Miss Brown's group from Mr. Ali's group and give your answer correct to the nearest degree. So this is where we need to be sort of a little bit more careful with our diagram. We actually need to add something to it as well. All right. So first of all, go back to part C there. It says find the bearing of Miss Brown's group from Mr. Ali's group. From. Now, it's a very important word. The location after the word from is our reference point. So what we're going to do is we're going to draw another north-south axis parallel to the original one. So I might just draw that in lightly. Just there. Okay, and I'm going to call this sort of north number 2. It's just sort of a parallel with the north-south axis there, number 1. And so we can differentiate the two ends. Okay, and what we want this angle here. Let's call that angle theta. That's what we want to try and find. That's our bearing. Okay, so Miss Brown's group from Mr. Ali's group. However, to work that out, we need this angle here. So I need this angle alpha just in there. Okay, so the angle between the north-south axis and this line AB. But in order to find that, I need this entire angle PAB. Now, first of all, part of it we can find out. So we can use parallel lines, alternate angles. So you can see there's a Z shape there. So if you follow the pencil, north, so N, P, A, and then sort of down south there, you can see it like a Z shape there. Okay, if I turn it on its side, you can probably see the Z shape now. So like that. So this would be 35 degrees here as well. Okay. So in order to find angle alpha, we need angle PAB. And we could use either cosine rule or sine rule. Since we have 3 known sides, so we can use the cosine rule, or if you have a side angle pair, it's probably easier to use the sine rule. The cosine rule is a little bit more complicated to use and probably takes a little bit more time. So let's use the sine rule here. So we have a known angle and we have a known side now. This is the side that we found in part B. And we need angle PAB and we have a known side opposite PAB. So there's our other side angle pair there. Okay. All right. So by the sine rule, okay, and we have angle, okay, so actually sine of angle PAB over, I'll go back to the diagram there. So this is our PAB over 9, okay, is equal to sine of 65 degrees over 8.76. Okay, I know I've rounded it, but there's more than enough decimal places there to get our answer correct to the nearest degree in this question. Okay, so let's find angle PAB. All right, so just rearranging the formula, sine of angle PAB, okay, is equal to 9 times sine of 65 degrees over 8.76, right, and angle PAB is equal to the inverse sine. So if we move sine over the other side, okay, 9 times sine of 65 degrees over 8.76. Okay, and let's see what we get there. Okay, so inverse sine. You can see that okay? Yep. 9 times. Okay, so sine of 65 degrees over 8.76. Close bracket. And at 68.61, which is probably closest to 69 degrees. This is probably the one instance I would say just rounded to the nearest degree, since we're going to be working to the nearest degree anyway. And there's nothing else on the diagram that's rounded, that involves decimals. Everything else is just whole numbers. So we might as well just express PAB as a whole number. Okay, so we have PAB's 69 degrees. So this whole angle here is 69. We have part of it is 35. So let's find angle alpha. Okay, so angle alpha, okay, is equal to 69 degrees minus 35 degrees, and that equals 34 degrees. Okay, so this angle there is 34 degrees. And alpha, okay, and theta are supplementary to each other, which means they're angles on a line, which means they add up to 180 degrees. Okay, so theta, which is our bearing, is equal to 180 degrees minus 34 degrees, and that equals 146 degrees. So therefore, bearing of Miss Brown's group from Mr. Ali's group is 146 degrees. Question 32. The diagram shows a regular decagon, 10-sided shape with all sides equal and all interior angles equal. The decagon has center O. The perimeter of the shape is 80 centimeters. By considering triangle OAB, calculate the area of the 10-sided shape. Give your answer in square centimeters, correct to 1 decimal place. Okay, so let's have a look at triangle OAB. Oh, here we go, this little slice there. In fact, if I turn the exam paper around, what sort of a triangle is it? All right, this is an isosceles triangle. So we can find that angle in there. So I'm just getting you to sort of think about a strategy here, or think about a plan of attack. So finding the angle there, we can certainly do. You might think, well, okay, why would I even bother trying to find the angle? We need to find the area of this triangle, ultimately. 10 of these triangles, there's 10 of these triangles that will fit inside this regular decagon, and each of those 10 triangles will be identical. So if we can find the area of one of these, multiply it by 10, we found the area of this 10-sided shape. So let's narrow our focus now onto this isosceles triangle. In fact, what I might do is I might just draw it here, so it's a little bit larger. Okay, so it's not to scale. Okay, and there's O, all right, there's A, and there's B. Okay, now we know that the perimeter of the shape is 80 centimeters, so we're going to mark sort of some information on this. And there's 10 equal sides, so perimeter, so AB, is equal to 80 centimeters. Divide that by 10, okay, which equals 8 centimeters. And we could mark that on our diagram, okay. And these are equal sides there as well because it's isosceles. Now, angle AOB, so that's this angle here, okay, this angle there. Okay, angles at a point add up to 360 degrees, so there's a little bit of geometry that's required here. So angle AOB, and there's 10 of these angles, so they're all equal angles. In fact, it says it here, right? All interior angles equal in the question. Right, that's equal to 360 degrees, and divide that by 10, and that gives us 36 degrees. Okay. Now, since triangle AOB is isosceles, right, then base angles must be equal. Right? Angle OAB equals angle OBA. So that's this angle here and this angle here. So just to sort of show you there on the diagram. Okay, angle theta. Okay. And that would be equal to, okay, I might just put it here, okay, 180 degrees minus 36, so that's minus this angle, and we divide that by 2 to get one of the base angles. Okay, so let's do that. 180, right, so I'll get it in the right mode first. Okay, 180 minus 36, divide that by 2, and we get 72 degrees. Okay, so I'm going to mark that on the diagram here as well. Okay. Okay, so what do you think we do next? Have a think about it. We've got a side, we've got an opposing angle, so that's a side angle pair. Okay. We need the area of this triangle, so we really need just one more side, and if we can get one more side, then we can find the area of this triangle very easily, and then it's just 10 of those. Okay, so just have a think about that for a moment. Okay, so we're going to use the sine rule here. Okay, when you have side angle pairs, it's a non-right angled triangle. We're not going to use Sohcahtoa because that only works with right angled triangles, so this is definitely the sine rule, and we need to find really one of these sides, either OB or OA. They're the same. It's like the radius of a circle, isn't it? Okay, so let's find x. Okay, so by the sine rule, okay, so we got x on sine 72. Oops, I'll just fix that. X on sine 72, yep, is equal to 8 on sine 36. Okay, I wanted to have the x first, so it sort of becomes the subject of the formula. I was going to write 8 on sine 36 first, because sometimes writing the known side angle pair sometimes can be a good strategy, but I want to solve for x, so we'll just write that first. All right, multiply both sides by sine of 72. I'll take up a little bit of extra space here. X is equal to 8 over sine 36 degrees, and we're going to multiply that by sine of 72. All right, and I'm just going to write the full decimal answer. Not a good idea to round at this point. We'll round the answer at the end. Okay, so 8 on sine 36 multiplied by sine of 72 Okay, and we get 12.94427,191. Okay, so that's, well, might as well write. Okay, so that's what that is there. Now, we've got all known sides, all known angles. So we can use the area rule for triangles. That's the half AB sine C. Okay, so the area of decagon, in fact, okay, is equal to. Now, first of all, we need the area of this triangle first, OAB. Yep. Okay, that's going to be half AB sine C, so that's, we're going to use our area rule. Half AB, so that's 12.944, okay, 7191. In fact, we're going to multiply it to itself again. 12.94427,191. Half AB times sine C, okay, times sine C. So half AB sine C, that's sine of 36 degrees. And then I'm going to multiply that by 10. Okay, and we'll round our answer at the end. Okay, so now I don't want to lose that answer, and I might just show you something here. Probably not a bad idea to do this. I'm just suggesting perhaps we can store that in a memory location. See that red letter there? I don't know if you can see that, just above the closing parenthesis there. Shift RCL, you see store up here, X. All right, and it puts that value there, so you don't have to type it out again. And it's a lot more accurate than using the answer key on the calculator, because this could actually go wrong if you're not careful with it. All right, so let's now work out the answer. All right, so half, okay, half AB, okay, but it's actually times X, all right, times X or X squared, okay, times sine of 36 degrees, multiply that by 10 of those triangles, and we get 492.429, okay, 0.429 ... and rounding it to correct to one decimal place, that's going to be 492.4 and square centimeters.